You don't have master key control.
Okay.
Whatever it is, man.
Side by side, you hear that one? Turbine lube oil tank. Over here we got our purifier. Auxiliary cooling water, it's cooling all the equipment, the plant, got the heat exchangers, the pumps, all your oil cooling, everything runs off auxiliary cooling water. This is pulling the water out of the oil. It's a lube oil dehydrator. It pulls the vacuum, 140 degrees, to pull the water out of the oil. That's just the surface condenser. That's all the condensate going back to the surface condenser. All the different drains off the speed drains. Pumps. They're taking the water out of the surface condenser and pushing it back through the heat pump. This is the water coming out of the surface condenser going to the condensate pumps to go back to the boiler. Got 3 condensate pumps. That's the surface condensers up there. This is the water coming in to cool the surface condenser. We got makeup valves and stuff. It's called the condensate pit. Pulling out of a vacuum, you got a vacuum in there. So it dumps down the pump wall. It's about 34 feet deep, so it actually gets back to a pressure instead of being a vacuum. Condensate pumps. That's the discharge line. That's going back to the boiler eventually. Cooling water going in and out. So surface condenser, you got your inner pass, the outer pass, about 180,000 gallons of water a minute. These pumps pull a vacuum on the surface water so they don't get air built up. These are your main vacuum for the surface condenser, pull a vacuum on. Pull a vacuum, straight vacuum pump. If you gotta have a vacuum on your surface condenser, it runs a lot. lock down the generator breaker, one for each phase. That's the breaker control panel. This is the power coming out of the generator. You're pushing this. Oh wow. Yeah, 60 pounds hydrogen there. It's about at least 12,000 amps right now. About 500 megawatts. That's for cooling the isophase buses. This looks at frequency monitor and ensure grounding for the generator. Power coming out of the generator right here, and there's your 3 breakers. As part of the hydrogen cooling system for the generator, you get a lot of heat load. So you got hydrogen generator, conduction, get a lot better reciprocation. It goes through the gland steam cooler. You have to seal the turbine. You got to put steam on the low pressure end to keep the vacuum in, and then put steam on the high pressure. Water comes out there, comes down the molecules. It has to go back through the 3 feed water heaters. These are the level control for the generator. We've got the condensate pumps, polisher, heaters, and that's the generator. That's your feed pump turbine. This is the booster pump gearbox. This is making the water out of the generator, boosting the pressure up. It goes through 2 more heat exchangers, and then it comes back through the main feed pump. These are various drains, like this is the generator drain right here. Pretty critical valve. These other ones are dump drains for your feed water heaters in case you build pressure up. That's called the BTV bleeder trip valve. When you get high level, it's a check valve, won't let water back to the turbine. And also if you trip, it closes because there's enough heat in the feed water heaters to drive the turbine. So if you trip, it could drive it over speed. 2-phase pumps. At about 2,800 psi, we're down in pressure limits. Let the pressure keep the turbine pilot going. 2-phase pumps at 300, you have to have the other one running. These are about 290 megawatts. We put the other one on. Phase water heaters. There's 3 phase water heaters in the surface condenser. Part of the gland steam makeup for sealing the low pressure turbine. At full load you got too much steam, so then you got to dump some of it back to the surface condenser. It's taking steam off the high pressure turbine glands. Then we cool it and use it for sealing in the turbines, otherwise you'd suck air and pass the seals into hold a vacuum. That's main steam going to the turbine right there. It's 2,400 psi, 1,005 degrees. Then you have your cold reheat coming back. It's about 600 psi, 600 degrees. Then you have your hot reheat. It's 1,005 going back in to the intermediate pressure turbine. You got various breaker load centers. Power here is 7,200 volt. This is all the exciter breaker, exciter control for the generator. You have to put a current to the rotor, produce magnetic field to run the generator. This is the demineralizer unit. We're making pure water to feed the boiler. Makeup. This is the Stator cooling water skid. There's water going down the windings in the generator for cooling. That's a very pure water. Transformer, 235,000 to 7,100 volts.
What's all the CBAs for? Is it for like fire or something?
Yeah. Firefighting.
Okay.
Your main transformers, 24,000 volts coming in, steps up to 500,000. You got 3 of them, then you got a spare. This is the auxiliary transformer, drops the voltage down for the plant off the isophase bus. These are the polishers. They're a resin bed. They clean up the condensate before it goes back to the boiler. You got 3 vessels and you got 2 regen vessels. You got to move resin to regen it. So it comes out of the condensate pumps to the gland steam condenser, polishers back to the feed water heaters, generator level control valves, and it goes up to the generator. Comes off of that through booster pumps, through more feed water heaters, main pumps, and back to the boiler. That's an electrode boiler for heating the plant. Gas and caustic storage for regenerating the resin. Plant air compressors. Over here you got the blaze. It's a water filtration unit. So you bring the water to the reservoir, you filter it, go through the demin, take the minerals out. Then it goes to the storage tank, and that's used for makeup for the boiler. Somebody's washing down. They got water in that thing, blew it up, knocked 2 ID fans out on us. We lost the plant later. This is the backup generator. It runs all the critical equipment. There's 2 Deutz diesel engines. 2 12-cylinder engines, they bolt together. That's the Aux Boiler. Use that for starting the plant up with. These are pumps for the Aux Boiler. That's your diesel fuel pump. It runs your igniters. Fuel the Aux Boiler. You have to use diesel to run the igniters to light the coal off with. Pulverizers. Each pulverizer feeds 1 deck of burners, 4 burners. That's the old style there. The new ones, the wheels are stationary. Those, the wheels actually rolled around. They're on a planetary. See the pin up there, that's how much coal is being crushed. You see the pin, how far out the rollers are. Chemical tanks for boiler water chemistry. Lube oil skid for each feed pump. That's the north feed pump, south feed pumps down there. That's your lube oil temperature. These are your bottom ash booster pumps. Use high pressure water to move the ash out of the bottom of the boiler. Bottom ash hopper. Twice a week you have to open those doors up, use the jackhammer, sometimes break up the big rock of ash. So every Tuesday. Hey. to come from that door, you got to pull the ash out. Use rakes. The crusher sits right down there. There's a crusher crushes up the ash. So you got to pull it out. You got to light fire. You got to have a dangerous job. The water level's up to there. The whole bottom of that hopper's full of water. The ash falls off the boiler walls down into here. Twice a shift we'll pull it off, use the crusher and try to sluice it out. But twice we gotta go ahead and get the big ash out that won't go. Has a bad scraper in the Pulverizer. Stuff through here with the coal kitchen clean.
What's on the fire though? What's on the fire? Pulverizing coal.
Yeah, we've had fire come out of this thing, hit the wall over here where it's blowing out the pyrite off. Basically, the stuff that's too big to pulverize goes down the air vents. The bottom part of this is an air vent. It ends up in this pyrite hopper, and then you sluice that out. So this here is collecting all the stuff that isn't getting ground up. You have your air duct right there. You got hot and cold air mixing together. You want the outlet temperature somewhere around 140 degrees of the coal going to the pulverizer. So this is primary air coming in, higher pressure. It blows the coal dust into the boiler. You have valves putting steam in for sweeping steam. And nice steam in case it gets hot, catches fire. They will catch fire. They will plug up. You can have disasters. Back there's the rest of the Aux cooling water. Like I say, every oil cooler has it's not Aux cooling water, it's clean water. Put out raw water. The hydrogen comes in for the generator on that truck. We have about 60 pounds hydrogen in the generator. CO2 tank, firefighting, inert in the generator. Lube oil, storage tanks for the generator. Different sightings where they blew the side of the building out one day.
Oh, wow.
That coal dust explosion.
Wow.
There's a Sentinel Lance.
Oh.
900 pounds of steam on that nozzle is what's blowing out and knocking soot off tubes.
Wow.
They bend, they stick in the boiler. We've had them get wrapped up. That's the water going back to the reservoir.
Wow, it's steamy.
Yeah.
Must be spray though,
Yeah.
like aerosol.
It's called the seal well. The way it's set up, you have your Cirque water pumps, or like propeller pump. Pump the water up through the tubes in the surface condenser and it comes back out. The theory is this maintains the level so you don't have to pump that high. It's producing kind of a vacuum help pull some of the water out.
So that's hot water?
It's not that hot. It's
Oh.
maybe 90 degrees, maybe 100.
So what's the total travel length of the water through the plant for the feed?
Okay, it comes in through your pumps. The
Yeah.
lines run underneath over to here and they go through the surface condenser and then they come back out.
Oh, just that building there in the end?
Yeah, we saw those big lines going up.
Yeah.
That's where they go. They go through tubes.
I can feel the heat. It's like the...
a
Probably
little
the
bit.
sun.
You can walk down these lines. We actually walked down and been down the bottom of this pit.
Huh.
And you can actually look at the pump and Cirque water. About 180,000 gallons a minute come through to cool the steam. A chlorine tank. We use chlorine to keep out the biological growth out of it. Chlorination room, just use chlorine to keep the clams and stuff from growing in all the surface condensers.
Wow, it is deep.
See fish? There's a bunch of fish in here. Basically have a trash rack. So we have these traveling screens that filter out all the big trash. There's a lot of ducks and geese on this.
Divers clean the screens?
No, we have these little racks. Back there's one of the rakes.
Oh.
That thing right there, you have to rake full of geese in the fall.
Oh, I see some bubbles from algae, I think.
Yeah, there's a lot of fish in this.
Yeah.
We'll go back.
Okay.
Traveling screen, real common.
Yeah.
This is the water coming out of the screen.
Oh, yeah. Watch out.
These are your Cirque water pumps. There's what's cooling the surface condenser. Another 2,000 horsepower motors. You have to run two of them on full load. In the back we have the service water pumps. They're cooling the aux cooling water and feed quite a few little plant water usage. Just filtering out the large grass and sticks.
There's the line.
Fire pump. dust. Higher than it should be, it's like 5% opacity. Surface water comes out down here. That's cooling. That's cooling water. This goes down here, goes underneath the pipe, goes underneath the reservoir, and comes out the other side. Big problem is the reservoir gets so warm.
Yeah.
You get 80-degree water coming back in. It's hard to cool stuff. This is Trona.
Okay.
Come out of Solvay. These are dehumidifiers trying to dry the air out going to the blowers to move the product so it doesn't cake up. Real cars are loaded pneumatically. Use air pressure and load the cars.
Powder like baking soda?
Yeah, you see a bunch of them around here. These are the blowers that move the Trona. 2 for unloading, 2 for pushing in for injection for sulfur control, flue gas. Sulfur out of the flue gas. This is Trona feed. The silos hold about 4 rail cars. So we're feeding this in the plant about 4,000 pounds an hour for controlling sulfur. Screw feeder set up for emissions. It maintains some quota to keep the sulfur down. These are Viper mills. They take the Trona and grind it finer. They water wash every so often, set on a timer for 24 hours. They water wash if you have high temperature vibrations. They'll shut down and use water to clean the rotor out. Over there is what's called the ash farm. Those two bins there is all the bottom ash. You have your bottom ash pumps. It's like gravel. It goes there, then once a week you dump it in trucks haul out. And the back one's your fly ash silo. Then over there, that's just the water's reclaimed. The water goes through, takes the bottom ash, ends up there. Sediment drops out, then we send it back in. So the water's usually reused for the bottom ash. What if we had to do start the fans while we're here? Primary air fan, this is blowing the cold in the boilers for the pulverizers. That's controlling the pressure on the duct going to the pulverizer. Those are like 3,500 horsepower motors. These are 2,000 horsepower motors running your forced draft fan. This is air going to the boiler. Part of the furnace draft control system would maintain about negative 0.05 inches of water. Other fan room. Backup compressors for cleaning the air preheaters. Plugged up with ice. There's such a back. Opened the door and sucked about 4 guys here. They got stuck in here. And then of course opened the door. Heating coils heat the air up in the winter months. Some of the stuff's blowing out of the pulverizer hopper. Get rocks and stuff build up, plug it up. That's your air coming in the pulverizer. Goes up through there. They got classifiers on top to control how fine the coal's getting ground. That's your air duct coming in. Primary air coming in. You got hot and cold air mixed together, maintaining the outlet temperature. This is monitoring the air, different pressures on the pulverizers. You got air going to the roller wheels, table seal, different sealing air to keep the dust out of the bearing. Guillotine damper, flow control dampers just down there. They got a passo damper, try and shut the air off and shut the pulverizer down. You have your hot air duct down there, it's about 670 degrees. Then you have your cold air duct dropping in from up above. Mixing the air right there. Those are cold air coming in, ambient air. Hot air comes in, got two sets of dampers, they mix the air. That's the cold dropping in from the feeders. This is the cold air mix going to the burner deck for the boiler. So you feed one burner deck, 4 burners off one pulverizer. Air's about 140 degrees. They only feed about 135,000 pounds an hour. Boiler drains, both sides have a set of those. That's coal going down to the steam pulverizer. This is the coal being fed right now to steam pulverizer boiler. It comes off the boiler master. Maintain so much coal in the belt, they can change the belt speed to control the feed rate. The condensate comes out of the surface condenser, goes to the gland steam through the polishers, back through 3 feed water heaters, and through feed water heater 3, then it goes up to the aerator. Then the water comes down, feeds your booster pump. This exciter housing, those are the brushes putting the current on the rotor shaft, Bruce magnetic field, run the generator. It's static drive off those controls downstairs. Bearing lift pumps, they use high pressure oil, keep the shaft off the bearing when you're shut down. This is the back end of the generator. You got your seal oil, comes from that skid downstairs, trying to hold the hydrogen in. You got about 60 pounds hydrogen pressure. So you got oil in a sealing system to keep the hydrogen in. gear, those are pulling any current off the shaft. You get the static charge built up. There's the bearings. You got a fire system on the turbine bearings. There's a vacuum on the low pressure turbine, so you're using the gland steam to seal it, keep air from running in. The shaft's been about 800,000 horsepower out. It's been about 500 megawatts. We can put out almost 600 in the right conditions. You got two low pressure turbines. This is steam coming from the boiler, 2400 psi high pressure steam. You got your turbine throttle stop valve, one on each side. Then it feeds your governor valves. There's 4 on each side. They're what's controlling the load out of the plant. So you have your turbine trip throttle, then you have your governor valves. Goes to the high pressure turbine, steam comes out about 580 psi, goes back to the boiler, reheated to 1005. Then it comes to the reheat. That's your reheat stop valve. Steam comes back to the boiler, has a reheat stop, then you have your intercept valves. This is all reheat steam. Goes to intermediate pressure turbine, then from there it feeds both the low pressure turbines. That's the feed water heater. There's the Preheater that goes up to the boiler. You got 7 feed water heaters, number 7. It takes the steam called cold reheat and feeds, well, actually, it's heating the water going back to the boiler. Same as the other side, 4 sets of pulverizers, 4 sets of feeders. Feed water heater 6. It's coming off the IP. It's just heating the water. You're trying to recover most of the heat energy you can to make the plant more efficient. Feed water heater 5. On. We'll go in the control room.
Okay.
INC shop.
Huh.
Here's the laboratory. Check chemistry.
Here's all the boiler water chemistry. Every shift we just verify they're working right. Boiler PA, specific conductivity, cat conductivity. Cat conductivity takes out all the cat ions. We had ammonia It mostly strips out so it tells you exactly what's going on with the boiler.
Wow.
Silica plates out on the turbine blades. Sulfite and chlorides can cause intergranular corrosion stress cracking on turbine blading. So this is all the water chemistry right now we're going.
Huh.
Little lab, you got the examples of each ship. Check pH.
Well, it's like continuous feed from different parts of the plant.
Yeah.
Well, that's easy.
Yeah. Yeah, the chiller maintains the water temperature. You have to have your sample temperature right around 4 degrees, somewhere around 75 degrees. So you have to maintain your sample temperature. Some of this stuff's coming at 1,000 degrees.
Yeah.
pH analyzers, the cat conductivity column. It goes through a resin. What turns yellow, resin is exhausted, so it's stripping all the positive ions. Here's a bunch of analyzers. These are all the sample points of water coming in.
Okay.
They have a thing called the drag valve. It drops the pressure from 2,400 down to, I don't know if they've set it right now, about 80. Yeah. So, this is where all your samples come in. You have to drop the pressures, you got to control the temperatures, and then it goes to the analyzers. This crap's worth a fortune. $100 a pound.
Wow.
We got our filtered water tank out there, and it's pretty dirty. So it goes to the blaze, we filter the water, and then it goes there. Then from there it goes back to the D-min, strips all the minerals out, and then it goes to the storage tank outside for makeup. Yeah, any screens you want to see? Or?
So they're making 530 megawatts.
Yeah. Oh, it's a good screen. I'll do a pulverizer. You can see it's downstairs.
Well, I could see all the things from everywhere.
Yeah.
Huh.
We can't control them here,
Yeah.
which is good. You don't want nobody screwing with anything on you. Here's that A pulverizer with the sparks coming out. You can click on this. Here's
Those were the pulverizers where those sparks were coming
yeah,
out?
that was a scraper, yeah.
Okay.
Right now we're feeding 99,000 pounds an hour. Airflow 188,000 pounds an hour. Outlet temperature is 130. We'll go down the simulator, makes more sense. What's a good screen? Voltage control. Here's the generator pressure right now is 60 pounds.
So what's the hydrogen used for?
Cooling.
Oh.
You just keep it on there. It's a lot less windage. It's like 0.7% of the mass of air, so the windage is a lot less and conducts
What's
heat
on
a
your
lot better.
main feed water condensers?
It's just in the generator.
Oh.
The feed water right now.
For your turbine?
Yeah, just for cooling the generator.
Oh, that's it?
Generator
Okay.
cooling only.
Huh.
Right now we got 28 megavars lead. Actually, we're boosting a little bit now, 26 megavars. This is kind of floats. You have automatic power system stabilization. Tries to take swing out of the grid.
Huh.
Radio frequency monitor. It's looking for arcing sparks in it. So you have 12,800 amps going out. These are your kiloamp ratings going out. Main transformer temperatures. Here's your voltages. Right now running 546,000 volts on the line going out. Exciter controls. You got automatic voltage regulator. It's maintained the voltage automatically. If we're putting it online, you got to close this and you got to adjust these and play with the speed. Once you get it synced, then you throw and close the breaker. But hydrogen's a great cooling substance and there's no oxygen to give you any corona damage to the windings.
Huh.
So we got water actually going down the stator windings. They're actually square tubes. And water goes down from the stator cooling, and then we use hydrogen gas to cool the rotor and the rest of it. I'll go to the feed pump. Here's your two feed pumps.
Okay.
Oh, they're pumping out 1,800,000 pounds an hour each one.
So you got two sets. All the transmitters, you have two sets of transmitters. If one goes bad, you can use the other one. So we're feeding 33,000 pounds an hour. About 3.3 million pounds an hour. We'll go to boiling water. Steam flow is about 3.5 million pounds an hour of steam. That's the boiler drum. These are all the level controls.
Yep.
We have multiple transmitters. Red means this is the transmitters we're using right now.
Okay.
So you got your level, and then you got your pressure. So red, we're running on the, it's like the south side. There's a little difference in variation in drum levels.
Huh.
That's from the way the water's going through there. These are all we got two sets of transmitters for everything right now. This is the transmitters we're running on. So we got 1.4 million pounds an hour of air going in. North sec. This is the primary air control. It's feeding about 1.3 million pounds an hour. Furnace pressure 0.71. These are around about 0.5. The way the furnace pressure works, your ID fans pick up, then your air picks up, then you can change your fuel. Pretty complicated control system.
Yeah.
Okay, we'll head upstairs. Pretty much have to know everything the transmitters are.
Wow.
Chain, it takes all the fine coal back. Here's your main belt. You have a gate that moves and controls how much coal goes on top of the belt. The way these gravimetric, they're actually measuring the amount of coal going in. So they maintain so much weight on the belt, and they change the belt speed to control the coal flow. Jobs dump those pans every so often. Oh shit, I gotta get my stuff. Docks is going about 35 to 55 miles an hour. That's your coal mix and air out the primary air fans going into the burners. Oh, here, take a picture of this. This steam here is used for like polisher regen, steam in regen, heating the caustic, putting seals on the turbine, and plant heating. Also, if there's not enough steam come back, use this for generator heating. These are boiler safeties. 3 on this side, 4 on the other. We'll go down here and take a trip across the boiler. Usually that's coming off the cold reheats your aux steam through a pressure controller, so we get too low, you got to come on these, take it off the boiler steam. Somewhere around 300 megawatts, you got to start swapping over. That's the steam coming out of the boiler, outside of the finishing superheat. This from here, it's heading down to the turbine throttle stop valves. This is the very top of the boiler. The whole boiler is suspended from these beams. That way it grows down, expands about 11 3/4 inches. These are superheater sprays. You have to control the temperature in your tubes, otherwise you can damage metallurgy. So these are controlling the steam outlet temperature. Every other weekend we wash the whole thing down. You got hoses to wash the whole powerhouse down one side. Yeah, it's hotter than hell. We haven't done it lately. We were supposed to do it last week and we didn't. So you have a hose up here, spray it, wash this whole thing down. On the roof. That's the steam drum down there. That's where the steam and water separated. You have a steam water mix that's coming up the risers. You have natural circulation in the boiler. Water goes down, you got steam water mixes lighter and it gets circulated. And here we strip the steam off the water and try and dry it, get the water out of it. Top the boiler. This was put in first before they did anything else. Coal cars everywhere. Out there's grassland, little substation. We got some of the main breakers for the feed some line coming in. You can barely see Mount Hood. Usually it's pretty clear. Some of the strobe lights you see.
Oh yeah, that's cool.
Yeah. That's your 4 DSI silos, Trona. Then you got the ash farm. Basically, the water just keeps circulating through the plant. Anytime you sluice bottom ash, it ends up in those ash bins. The water goes off. All the sump water goes out there, so we let the particulates settle out, haul that out. The ash dump sits over the other side of the reservoir. This the effluent goes across out there. You can see where the water's kind of coming up across the dike.
Kinda, yeah.
I think that's where it ends up at. Like a lot of money. They pump this out of the Columbia River.
Oh.
This gets pumped out of the Columbia River.
But they'll still keep the reservoir for a while.
Yeah, they have to have a little bit of water over there.
I see.
Then we have withdrawal pumps. We'll pump water out for the farms to try and lower the
Oh.
dissolved solids in it. They concentrate, so you have to change water out in there.
That's too bad they can't really use it for farms. Salt.
Well, they do. We change part of the water out every year.
Oh, I
We
see.
bring fresh water in, then they pump it out in the farm, so it keeps getting to solids. That's gone, we're done. That's the precipitator building down there. We're taking out all the particulate out of the flue gas. So that bigger silo with the 2 bag houses on top, that's where the fly ash goes. We haul that out pretty much every day on day shift. They take it out there and dump it.
How much ash does a ton of coal make? Does it like condense down a lot?
Yeah, it's like 4 or 5% ash.
Oh.
That's where we're running at.
Yeah.
Every coal is totally different. You can tell what you're running, amount of ash content, heat value, how bad it legs up the boiler. So coal's very different from where it comes from. Out back, they're reclaiming the coal. They have a company, RPM. They're taking the rock out and they're trying to clean up the coal they've scraped off the bottom, so there's nothing left. Got a lot of rail cars. Used to run 3 trains continuous. Right now we're going through about 7,100 tons a day. I think there's about 300,000 tons left, they're saying. So, building out there. It's where they unload their rail cars at, then it runs down these belts.
Okay.
The very far one's SR2. It's a manual stacker. You got to sit in the cab and run it.
This SR3, this is automatic. The one close to it, it runs by itself. Control button gets low, it quits feeding. When you need coal, it feeds. It transverses, does everything automatically. The back one, you have to be sitting in the cab and you got to run it back and forth and cut coal. Water tank, there's the trailers. They had some motorhomes they brought in right doing the prices. See that one tank, the cone roof, that's diesel. That's run the igniters, Aux Boiler. The other tank's fire water and kind of domestic water.
Has an oil pad ever been used?
No. They got lights over there you guys set out, they come in. That's where your coal's coming up out of those belts. The cars are all aluminum. They're aluminum rail cars, so somebody come give us a bid on them. This whole thing, it cuts down the water. Here you can see the way the hills like sandbars. There. Where the window is, that's where we're analyzing the flue gas.
Okay.
All your continuous air monitoring equipment's in there. You have to go up there and calibrate and check it.
What's that radio tower for? Like your internet?
What is for the ham radio club? They let them put a tent up here for the ham radio club. Basically, we monitor mercury, sulfur, carbon monoxide, look at carbon dioxide, water, particulate. So we got probably the lowest mercury in the country coming out of this plant.
Wow.
Sulfur's 0.95, 0.295. So it's pretty low. See a lot of these lines there for vacuuming out ash. Use a vacuum truck downstairs, run hose and clean out. This is called the Penthouse. That's where all your boiler tubes inside run to different circuits. It's not part of the flue gas stream. When they come out of the steam drum, it goes back to here. There's different part of the plumbing for the boiler. The actual boiler is down below. This is soot blowing station. Takes steam off the boiler, drop the pressure around 560.
Those are the flow control valves. Different sections of the sub blowing have different pressures and flow requirements. Steam drum. These are your level transmitters. You have your 2 pressure transmitters over there. Right now we're running on the other side. So you got 3 level transmitters each side, 2 pressure transmitters. These are your spray control valves. When they finish in superheat, they're controlling the outlet temperature of the steam, trying to keep it under 1005. That guy just went closed. One side's running hotter than the other side. I don't know why. Auxiliary steam station. This, like I say, this is used for when there's not enough cold reheat steam to run the aux steam. Steam going to division walls to control metal temperature. Basically, the steam comes out of the steam drum, goes through the top tubes in the boiler roof, goes to the primary superheat, comes out of primary superheat. It's sprayed down to about 880 degrees. Then it goes to division walls, and then it's sprayed before it goes to the finishing superheater to control the temperature. So there's 2 sets of sprays to control the steam temperature. Packing on that one. Bad packing. These things, the sub blowers are key. You shut down sub blowing, you'll slag up the boiler and go on high temperature. Sub blowing has to run. You're cleaning all your back pads. Your reheater sections, the back of the boiler, primary superheat, and economizers this side. This guy's going down. I'll let the water blow up before we go past it. These are smart sub blowers here. You control how fast they go, how much they sweep. There's a lot of stuff you can control. We just run them straight in and out. You have your finishing superheat tubes in there. Where do you get a picture of it? Open the door, maybe get a picture. side, that one might blow some steam down. Division walls are inside here. It usually throws fire out when you look in there. Might do that one real quick.
Yeah. What's the furnace? There's oil streaks inside there. Glad you're looking in. This one starts up. You got to find that real quick.
Flag off. The melted coal particles stick to the tube. It's amazing, some of the pictures come out really good on this stuff. And I can take pictures myself. Yeah, these are good for 6 inches. Good with the pickup. It's just got built really bad. Yeah, oh, that's right there. Man got melted. That's how you get something blowers out. Wow. Go in there and stick, stuff breaks, you gotta get right there and drive them out. It could be a hell of a project. Wow. So they're stuck back there, you gotta hold the air ratchet, drive them all the way out sometimes when they stick. These are all the downcomers. This is all water going back down to feed the water wall circuits. Okay. This will be 18 of them, 16-inch pipe. here, this thing flips up and supports the lance. Holds up on lance. Got that, this one on the other side. Out header. This is the feed water coming out of the upper economizer going to the boiler drum. We have a thing called a bowl nose that kind of goes out. It keeps the furnace gases a more uniform pull on the boiler instead of just pulling down the back wall. You've got division walls that come a long ways out into the firebox trying to pull heat out. Then it goes to the finishing super heat, tries to pull more heat out. You get much above 1800 degrees hitting the primary superheater. Seems like it plugs it up. It's about 2200 degrees coming off the top of the bowl nose in the back past the boiler. That's an infrared temperature probe right there. It's measuring the temperature of your bowl nose. Should be around about 2200 degrees. Some of these have pretty bad vent lances. They'll sit here and bang when they go in, they get bent from lack of steam flow and heat. This there's way out in the boiler, a pretty hard part of the fire. Just cleaning the division walls, mostly a little bit of finishing super heat. They're supposed to go in and stop, you know, and swing and do this. Well, we just run them continuous.
fan room for the turbine generator. Turbine room sits right down below us. A little bit of vapor that's coming off the extraction off the lube oil. We keep a slight vacuum on the lube oil system to pull in air so oil doesn't get out. If you ever have a turbine lube oil fire, it could be a complete catastrophe.
Huh.
Where's Denise at? I didn't see her.
Probably bottom of that shack run across someplace. Yeah, that's all there is 5 people can have chip soup, 2 out in the boatyard.
Wow. Not much.
No, a little bit of vapor that's coming off the gland steam. It's important to keep the turbine sealed. If you lose your gland steam, you can't maintain your vacuum and it'll trip off. So you take the steam off the high pressure that's blowing out, you cool it down, and then you send it to the low pressure end to seal it. For startup, you have to use auxiliary steam to keep steam so it doesn't pull air in, then you can pull a vacuum on it.
Huh. So where's the turbine at? Is that in that room?
Yeah, it's right down below.
Okay. So there's a turbine room and then a transformer room.
Transformers sit outside.
Oh. Out there, the substation?
Right down below us.
Oh.
See the wires coming off there? They're coming off the transformers. It
Okay.
goes out the ISO phase bus, 2400 volts. Then we stepped up to 500,000.
Yeah.
Still pretty high current going down those lines.
I bet.
But you got like 10,000 gallons of oil in the transformers. And every time they fail, it can be a pretty big disaster. That shaft's not that big, a 16-inch shaft. You can put out 650 megawatts.
Yeah.
A lot of power. The plant takes about 30 megawatts to run all the fans. Enough of a small city.
Like fans and pumps and stuff?
Yeah.
Okay.
Right now we're putting out about 530 out of the generator, and we're sending about 500 down the line.
Oh.
Those fans, a lot of them are 2,000 horse motor. You got like 10,000 horsepower on horse drive fans and 10,000 horse on ID fans. If you want to experience hot, we can go down there. It is hot.
Okay.
Slight bend to it, just a little bend, that's not too bad. Did that before, we have to cut them off, drop in the boiler, you can't get them back out. One time it rolled up like chaff and it rolled out itself. Yeah, that's why you have a lot of steam flow. It's at least, I don't know, 2,200 degrees in there, you're running your metal, it lands in there. With all that weight and length, they bend pretty quick. So you gotta have pretty high steam flow. These have like 12,000 pounds an hour steam flow. Intermediate furnace sprays, these are cooling the steam to the division wall. This is coming out of the primary superheat. The steam right comes out of the steam drum to the top rows, primary superheater.
Comes out of the primary superheater. We spray it down to 870, 880 right now. Then it goes to division walls, goes back up, sprayed again, and then it goes to the finishing superheat to try to maintain 1,005 outlet. That's steam set going to the division walls. This is water, feed water coming from the lower economizer to the upper economizer. It goes to your economizer, comes out the bowl nose, goes to the steam drum. So you're always trying to extract heat every step, trying to keep the heat in the system. These are the dampers. This is for the primary temperature control. It's mostly for reheat control. This part right here is your primary superheater and upper economizer. This part's all reheater. So these dampers try to maintain 1,005 outlet on the reheater. They work where this will open, this will close, or opposite to maintain flow through the boiler. Yet maintain your reheat temperature. Feed water coming in the boiler. It's coming through feed water heater 7 off your main boiler feed pump. Got a little valve there, LV7, that's used for startup. We run that manually for maintaining level and when we run low loads. At 1400 psi, this thing swaps over to 3 element control instead of 1, so you're looking at feed water, steam flow, and level. This just looks you just run this manually, it looks at level. That's the feed water going to the lower economizer. Boiling right around, I don't know, 7,000 gallons a minute. The water hammered the plant and broke one of those lines, the reheat. It smashed the floor downstairs, went down here, did a hell of a lot of damage. Somebody wasn't paying attention to a valve. Top of the coal silo. They hold about 480 tons of coal, a little over 4 rail cars, almost 5 rail cars. You fill your silo, it goes down to the feeder, it regulates the amount of coal being fed down to the pulverizer, and the pulverizer blows it up into your deck of burners, 4 burners. The boiler master controls the amount of how fast your feeders run, controls your boiler load. Have your firebox, that's where your fire is. Then these are the convection section. You have your primary superheat and your reheaters on this part. So the flame fire goes up here, loops over, comes back down. These are some of the old water cannons. You just use water for cleaning the boiler walls. That's a water cannon. It uses high pressure water to clean the furnace walls. They can go up to 500 psi. Usually about 300 psi. You can control how fast they move. They're set up in zones. They'll actually clean zones. They're a pretty amazing machine. The XY drives are accurate to like 6 decimals. It's German. It's very complicated, but it works pretty well. We have vortex coolers. Use high pressure, use air, and it spins it and it makes a huge cooling effect. So you use air to create a little cooler to cool the cabinets. Everything uses vortex. These are mostly just an I/O port and the actual PCL is down lower. So the logic and the programming is pretty complicated. Yeah. That's just the water can't use high pressure water, knocks the slag off the furnace walls. You can set what zone you want to blow and stuff. They're pretty neat. You gotta keep slag off. Slag will build up on the wall, start getting high temperature going in the back, makes a lot of problems. You also get a lot of knocks too. Nitrous oxide, you know, smell the barbecue.
Yeah.
This is where the wind box starts. Your 4 strap fans push air in the boiler up through here. On top ones you have over fire dampers. You put air over the top of the fire, try and knock down knocks or unburned. Then it feeds all your burners. Your 4 strap fans just feed this part, whereas your FD fans feed the pulverizers only. Part of the aux cooling water head tank. This maintains pressure in aux cooling water. That's the deaerator storage tank. You got about 3 minutes of water if you lose a condensate. That's the deaerator up there. That's stripping out all the dissolved oxygen and gases out of the water. You have a flash recovery tank, takes a continuous stream of water off the boiler drum. The steam flashes off, goes to the aerator, and the rest of the water goes down to the hot well, surface condenser. That way you keep down the concentration of the boiler. Well, the feed pump recirc valves, you have to have minimum flow through the feed pumps or damage them. So those are set to maintain minimum flow through the feed pumps. This is floor 8, that's floor 9. Don't ever take the elevator between 8 and 9.
Oh.
One day I was with some guys, they had to get the lunchbox. They got in the elevator at 8, they went up to 9, got out. This guy did, probably the guy finally lost it with him, the boss.
Wow.
Yeah, this is 8, that's 9.
Oh.
These are level, they'll trip your feed pumps off to get a little level. Takes the north at 67 and the south at 64. That's extraction steam feeding in your deaerator. It's coming off the low pressure turbines. Take part of the steam. Deaerator heats the water going to the boiler up and also extracts any salt gases out of it. You have aux steam for startup. We'll use this valve. Heat the deaerator and the water before you put it to the boiler. pretty fine. Had a lot of problem with dust, but it's a lot wetter, so it isn't too bad now. That'll be ground up about the size of flour blowing in the boiler.
Was this before the pulverizers or after?
Before, this is feeding. I'm feeding the silos.
Well, that's something you
Yeah.
Okay.
The silos right now are holding about 8 hours of coal. So you lose your belch, you got about 8 hours. You got, if they're set up automatically, they'll fill up, then they cascade. This one here is set on a weight, they'll shut it down. The control silo, this starts and stops them right now. You pick whatever silo you want to start and stop. The whole system runs automatically. We can bring in, not sure what they're feeding right now. We only got one crusher, so it's a little bit less. Hey, life isn't good.
yeah.
Those belts are filling up the silos. This one will fill about 400 tons. It goes down to the feeder, the pulverizer, and blown back up to the boiler. Growth in there.
Yeah, I can see it on the screen.
Yeah, it's like goes around the burners. You get a cleaner one. This one's kind of cloudy over here.
Better if it adjusts.
Yeah. Oh well. I can take pictures of it or something.
Well, it needs to adjust.
Cell phone's got real good.
There it goes.
Down below, that's coming off that one pulverizer. That'd be pulverizer G. eyebrows, those big buildups, they'll get wet. They drop down, so the bottom ash has to grind up. So you'll get those down, a big chunk of rock. Get out the jackhammer, break it up, and get it out the door. Just build up around. You can watch the slag melt off and melt and drip. So that's what bottom ash does. It deals with all the slag on the boiler walls. Kind of melted it. This is called the Economizer Ash. This is your ash dropping out of the reheaters and the primary superheat part of the boiler. This is the firebox. There the dampers are. This is the back part. So this is all the ash getting knocked off the soot blowing. It comes down here, is ground up and blown out to another tank. Fly ash is collected later on. Bottom ash builds up on the walls. Here's a basic burner. Here's your coal coming in off the pulverizer. You have your sleeve damper. This controls the amount of air going into this burner. You have your igniter, uses diesel fuel, feeds about 4 gallons a minute. The igniter has an air supply, diesel supply, then there's a high voltage spark plug that lights it. Then you have 2 flame scanners. That's the flame scanner for the igniter. It uses ultraviolet. This is the flame scanner for the main flame, your main burner. So they both use ultraviolet. So if you lose 2 flame scanners in the main, you trip the pulverizer off. Starting up, you have to get all your igniters in. Then you can start feeding the coal. When you feed coal, all 4 burners go at once off the pulverizer. That's Economizer Ash. It's just a buildup of the melted particles from burning the coal. Use your soot blowers to knock this off the tube. Then you have to grind it to blow it out. These are being fed off F pulverizer. Here's some of the stuff you find. It gets caught up here in the screens. These are guide protection tubes for the boilers. They'll put those on where the soot blowers hit them.
Yeah.
They'll put those on to keep from eroding the boiler tubes. The Cinder Grinders are grinding up all the Economizer Ash. They make it into small pieces, kind of like that, so we can blow it out of here. These plug up a lot. These can be a problem. Then your transport line can plug up. Economizer Ash.
Yeah, a little bit. Oh well.
Metal and all kinds of crap. It can be a problem. It's raining. You're making this size of stuff. Out of the bigger pieces that get knocked off.
No, just the fire.
Huh?
Just the fire.
Without this thing right. I could probably bring a camera and I'll get a lot of these pictures.
Okay.
Sets of water cannons. This is one of the lower ones. Number 3. Economizer ash transport line. Use air pressure, blow out the ground economizer ash out. That's the cold air feeding the pulverizers. This is the hot air coming out of the air preheater. We got a Venturi flow meter. See that one pulverizer, there's just 4 lines coming out. This one is feeding that top deck, number 6. The air preheaters, they take the heat out of the flue gas and preheat the air going in. It's about 670 degrees of air feeding in to the boiler. Activated carbon for mercury control, and this is trona for sulfur control blowing in. These hoses get leaks, send them and plug. You're up here. Sometimes it's the cloud up here. It gets bad because you got to hold them the lead. You got to splice them, and or they plug up. You got to take them off, try and blow them out. Oh, upstairs worse. It gets bad. Yeah, you got to run down all these things right for else running paths. The hose gets this not really abrasive. It cuts this hose through. You gotta patch them. I think we get it. This side you have the flue gas is coming out of the boiler, coming down this side, heat. On the other side you have the air going back in. So you're just transferring the heat out of the flue gas coming out to the air going in. Yeah. Use high pressure air to clean off the air preheaters. That's one of the floors, one at the top, one at the bottom. We can actually see the baskets inside. that's a lower support bearing.
Push the end, yeah.
Shut that door, right?
What?
You shut the door thing?
No. Oh.
That's about how fast the air preheaters turn. That shaft up there. Lower support bearing. Dampers a little pump. Have to inject chemical phosphoric acid and stuff to give the fly ash enough resistivity so it stick to the plates.
Huh.
These are called the transformer rectifier sets. They put about 50,000 volts DC.
Okay.
This is what's putting power to the plates to pull off the fly ash.
Huh.
A little bit of dust today.
Yeah. So what are these transformers for?
They put power. There's wires that put a charge on the particles. Then
Oh.
the plates have the other charge and they collect them.
Oh, for the
Yeah,
filter
it's
dust?
electrostatic.
Yeah. Yeah, I can.
This first set, these are the discharge wires. They're putting the charge on the particles, and these other ones are the collectors. They run every so often. We keep a little bit of ash on the plates, but they wrap and knock the ash down. So this is stripping out the particulate out of the flue gas.
Yeah.
It's called wrapper rooms. They have a curtain key lock. But first you got to shut the breaker off, grab that key, go up there to the TR, put the key in, turn it, take that key, take it to the outside, and you got all 6 keys there. Then you can get a key for this lock, and this lock goes upstairs. You see all these keys, you lose a key, you're screwed.
Oh.
You got to take that breaker key, TR key, and these keys. Once you put a key in here and turn it, it'll release this key. You can't get these keys out. So you have a sequence that you got to do to get the keys in order to.
That's good.
Yeah, you can't walk through. There's 50,000 volts on these wires in there. This is the wrapper breaker room. The discharge is continuous. Well, that's part of the air conditioner, that one. It's called the Shipbuilder Control House. These are feeding the TR sets outside. They look at how many sparks per minute. They start sparking, they back down the voltage on it.
Huh.
Big one. They're basically cut the waveform. They produce DC voltage out there, so these things cut the waveforms and the voltage out. Then it's transformed and rectified outside. So right now I'm trying to run about
350.
1,000 volts. 100. I think that's AC. Let's run about. This is the voltage going outside, and then it's stepped up. So. This one's running 54 kilovolts. That one's running 14. It's sparking, so it's backing down a little bit.
Oh.
Yeah, each of these, this is controlling the emissions. This is set up too. It tries to keep the voltage down as low as you can so you don't waste power. It takes a little over a megawatt to run this thing, but you can cut it by a quarter if you're unoptimized. the exhaust gas comes out of the boiler, goes to the air preheater. We had your Trona and carbon right before the air preheater, goes to the air preheater, comes down to the precipitator, knocks the precipitation, the particles out. Then it feeds down to your ID fans. They're pulling a vacuum on the boiler. They sit down there, and then the stack has a liner in it, and it goes up the stack.
Did you see the tower from
Yeah,
with your video thing?
a little bit. It should be. These lines where the DSI go on there, they plug up once in a while. Discharge wires in here. Okay. They're knocking the ash down the hoppers. Yeah. The hoppers and the precipitator. The ash is knocked down, filter goes down. They got Nuva feeders down the bottom that ship it out pneumatically. We've opened these doors and dumped ash. We've had ash up to the floor grate before. It's just fans, two secondary, primaries are on the end. This is Economizer Ash. Wow.
Might want your mask.
It used to be really clean and nice in here. It's just kind of gone to hell lately. This is a Nuva feeder. This is what's feeding out the ash. You have a bottom gate, top gate. Top gate's opens, there's an equalizing line that's open, lets it fill up. Then the equalizing line closes, it pressurizes with another air, then this valve opens, it blows out pneumatically. There's air going down this transport line. So it blows it out to the silo, so we're moving fly ash all the time. You collect the fly ash, then you blow it out to the hopper. It used to be really nice in here. This is what we used to control mercury with. black, all you do is see two white eyes. These ACI feeders are feeding activated carbon to control the mercury. We use the CHI product in the coal yard, and this pulls the rest of the mercury out. That carbon goes right through your clothes.
Man. It's slippery 'cause
These are the ID fans. We're pulling draft on the boiler.
okay.
2500 horsepower motor, the VFD driven, so you control the speed on the motor, control the draft. So if you change fuel, first these kick up, then your air kicks up, and then your fuel kick up. You're trying to maintain negative 0.5 inches of draft. Drive room, we can go in there. Light on. These are the VFDs for the ID fan. Each one we control the RPM, controls the draft in the boiler. They're pretty exotic drives. No problem. Tower. Yeah. Oh yeah. That's the 300-foot level.
Oh, so the window is for the testing?
Yeah, that's where your emission stuff is up there. So your flue gas goes through a line. Got an elevator. We've had guys get stuck up there. Going down the ladder. Yeah.
That's pretty neat.
Okay, nice.
Yeah.
Was this all convection current from the air getting sucked up by the warmer air?
Probably.
Huh.
Yeah. Yeah, you take the elevator for 300 feet, then you got to climb the rest of the way.
Wow.
To the top. Pull the air out, and the FD fans push the air in, the PA fans push the coal dust in to burn. Set up so they all run kind of the same RPM. You can bias them up and down, but the speed's what's controlling the draft in the boiler. The dampers are just for startup, shut down. The FD fans control off the dampers. The motors run continuous. The company that sells the fly ash, they used to use it for cement additive, but they use it now in the landfills. It will make like concrete when it gets wet.
Yeah.
That's the Economizer Ash silo. That's where the Economizer Ash ends up here, and they load it in the trucks once a week, haul it out. Maybe some of the bottom ash. Bottom ash, once it goes in through the grinder,
Okay.
it comes out in big pieces and you break it up and the grinder chews it up. It makes gravel and it's transported out here with water. The other ashes are transported with air. This is the bottom ash. It comes out in big pieces, big boulders. You have to break with a jackhammer or rake it, and it goes through that grinder and it makes gravel out of it.
Wow.
They transport water out here. They get a lot of trucks every week of it. It's called the ash farm. Those pumps take the sludge off the tank, send it back to the dewatering bins. Then you unload that out, it settles out. So you just try and keep the water clean. Those pumps send the water back in, so you have a continuous loop of water. It picks up all the sump water and all your sluicing water. Like I said, that we were up there with the coal belts. They actually blew the side of the building out that one time.
Oh.
Bruce was here then. They had coal dust build up, and
Like a bearing's going out or something.
it's just those screw feeders. You get a little buildup of trona. The trona build sets up rock. When it gets hot, it melts together. Any water, it sets up.
Yeah.
It's difficult. They built it in the lines and chunks go through the hoses. The first tank's demin water, and the second one's condensate storage.
Okay.
So we make up for the demin tank from the demineralizer unit. Then every 15 feet we need water, we transfer over to the condensate storage, and that goes to the hot well and maintains boiler makeup. The set boiling takes some water. We should be making up around 3,000 gallons an hour. tank uses antifreeze for the boiler water. Maintains cap conductivity and pH. Strict conductivity. Little jockey water fire pump. Maintains pressure on the fire system. We have a chemical addition tank. That's for add chemicals like for startups and shutdowns. That's the auxiliary cooling water heat exchanger. Surface water goes through here, cools the water, cooling all the equipment in the plant. That's one of the main uses of the surface water. Lots of cooling water. Firefighting gear.
Yeah. So is everyone a firefighter if they have to?
You have to go to class. I haven't done it. Probably should have.
Yeah.
A bunch of people in worse shape than me on it. We'll go to the simulator. An overview of the plant.
Yeah.
Dave.
Well, they've got every kind of screw and bolt you could think of.
Yeah.
Some of the tubes they cut out. This is the size of the tube in there. These are water wall tubes.
Wow.
Oh.
Pretty thick.
Yeah.
This is water wall.
Huh.
That hole there is probably one that damages we had to cut out.
Oh.
We had that one tube that had a crowbar in it. It cut through the pipe. They made a hole. They had a piece of, there's a bar in there that actually went through the thing. But these, they got to cut a window and then weld the backside.
Yeah.
And then
Like
weld,
a V-notch.
they cut a hole.
Oh, yeah.
Because you got to weld the backside, and this is all you have this side.
Yeah.
So they got to put the tube in there and cut. Pretty good trick, Mark.
Wow.
Here's the different tubes. That looks like a soot blower tube there that failed at the end of it.
Yeah.
Pretty thick tubes.
Probably on day shift, there's a lot more activity going.
One or two maintenance guys. That works.